Guys, today is the day that you are going to be doing Venn diagrams. I know you've been waiting for ages for this, but it's all going to come together, okay? I can tell you are very excited. We're going to be looking at using set notation with Venn diagrams, and we're going to be looking at shading and then doing it the other way around as well. So here's a quick starter question for you. Recap from last lesson. So you have two sets, A and B. List all the elements in set A union B, and then list all the elements in set A intersection B, or A and B. Okay, so for A union B, you should have got everything in A and everything in B. So you can see that 1 is common to both. We don't need to write it twice, we just write it once. And then you can see 2, 3, 4, 5. They both have 4s as well. 5, 6, 7, 8, and 9. And then for A and B, well, what's common to A and B? Well, it's going to be 1 and 4. So curly brackets, 1 and 4. Okay, so we can actually show sets in a diagram. So in this case, we've just listed them. So for example, set A is a set of all natural numbers from 1 to 5, inclusive. Inclusive means it includes 1 and 5. And you can just draw it like this. So you got 1, 2, 3, 4, 5 in the list, and you just put a circle around it. And then the normal way to list it is just using curly brackets, which you're familiar with. Another example is set B is a set of all even numbers between 1 and 11, exclusive. So exclusive means it doesn't count 1 and 11. It wouldn't count them anyway because they're not even, but that means that your set would be just a circle with the numbers 2, 4, 6, 8, and 10 in them. And again, you can just list it using set notation, just what you're familiar with already with curly brackets. So a Venn diagram is a diagram that shows the relationship between two different sets. So just a few examples. Here's two sets, A and B. In this case, I've randomly shaded in one part of it, and now that will make more sense later on when we get to shading. And you can see they overlap with each other. So there might be bits which A and B share with each other. There's another type of Venn diagram with 3 different sets. So again, you can see various bits have been shaded in. This bit right in the middle is common to A, B, and C. So whatever goes in there is in all 3 sets. You might have 4 sets. So there's an example on the screen there. Now, more than 4 sets, it gets very messy. You're probably not going to use a Venn diagram for that, but you can get more than 4 sets. Here's a practical example of what's common between a unicorn and a narwhal. Well, it's the horn, so that would go in the middle. And then also remember, sometimes things don't have anything in common, and that's very sad. So they're going to be very separate from each other and they don't overlap. So for example, if I said numbers greater than 5 and numbers less than 2, there would both be 2 separate sets. There would be no overlap on those. So there's lots of different ways we can use these Venn diagrams, and we're going to look at how we can relate the notation that you've already done with the diagrams that we're looking at. So the first thing you need to copy into your book is Xi is a Greek letter used to represent the universal set. Now, you don't need to remember that that is Xi, but you do need to remember that this is the symbol that we use. Technically, they're meant to mean the same thing, to represent the universal set. That means everything, all of the sets that you have in your question will be inside the universal set. So anything in set A or set B, or even anything that's in the question that's not in both sets but is part of the question, will go inside this rectangle. Okay, so the letters can be used to name the sets. So the green area here represents the elements in set A. So you can probably tell which area I'm going to shade it in. It's going to be this area. So all of that is set A. And I could also represent set B using the red area. Now you can probably figure out that it's going to be this part here. So that's all set B. Now, you may have realized that in showing you A and B, there are other parts of this diagram which we haven't really labeled, but we're going to need to find a way, for example, that all of that bit outside of A and B, or for example, this bit, just the middle bit, or for example, this crescent shape here. How can we represent those using set notation? Well, that's what we're going to look at now. So in your books, you're going to need to copy down 3 different things that you are kind of familiar with, but you haven't done them in diagrams yet. So new notation. We can shade specific parts and we can use specific words to represent these parts. So an intersection is where 2 sets overlap. So A and B, in this case, you can see they overlap here. So that is what we call the intersection. Now, when you are copying this into your books, do not color this in like that. It gets messy, and sometimes you need to have 2 or 3 colors that overlap. And in that case, it's better to just do cross-hatching just like this. That's good enough. So this represents the intersection of A and B. So it has to be in both A and B. Okay, the second thing you're going to copy down is the union. So the union of A and B is anything inside A, anything inside B, and anything that overlaps, or anything in both. So another way you might shade it in is maybe you might shade in B in a different direction. But anything that's shaded in counts. So that's called a union. And we don't double count the middle, even though it's in A and B, both. And then the third and final thing to copy down for this this part of the lesson is, this might be a new word, is complement. Complement is, it means not. Another way to say it is A dash, because you can see a little dash there. That's how we can write it. So the complement of A is everything outside